Understanding ventricular pressure, changes in the heart. The heart functions through a rhythmic cycle of contraction and relaxation, driven by changes in ventricular pressure. This pressure controls blood flow and valve movement, ensuring efficient circulation. Let's examine these changes alongside a pressure graph. During diastole, the ventricles are relaxed. The pressure in the ventricles is low, allowing blood to flow in from the atria. The atrioventricular valves are open, while the semilunar valves remain closed. On the graph, ventricular pressure is at its lowest. As the atria contract, the last portion of blood is pushed into the ventricles, slightly increasing ventricular pressure. This prepares the heart for systole. At the start of systole, the ventricles begin to contract. Ventricular pressure rises sharply. Once it exceeds atrial pressure, the atrioventricular valves close, preventing backflow. On the graph, we see a steep upward curve. As contraction continues, ventricular pressure surpasses arterial pressure, forcing the semilunar valves to open. Blood is ejected into the aorta and pulmonary artery. The graph shows ventricular pressure peaking. During the ejection phase, as blood leaves the ventricles, pressure begins to drop. This is reflected in the graph as a gradual decline. After ejection, the ventricles relax in the isovolumetric relaxation phase. All valves are briefly closed and ventricular pressure rapidly falls. The graph shows a steep downward slope. Once ventricular pressure drops below atrial pressure, the atrioventricular valves reopen, marking the start of a new cycle. The graph returns to its lowest point, ready to repeat the process. This synchronized cycle of pressure changes ensures continuous blood flow throughout the body.